Welcome to class, everybody. Today we're going to be learning about position, velocity, and acceleration. We're just going to do part of it right now. We'll just stop when it's kind of somewhat convenient to the clock, and then we'll pick it back up next class. So the first thing we're going to learn about is the average rate of change between two parts, either of a graph, of a table, or even just of a function in general. So the average rate of change. So this is something that you should kind of already know already, because this is like the slope definition. The average rate of change over an interval is given by this. And you've seen this before. This is just rise over run. You're just finding the slope between 2 points. Okay? So if I have like some graph like that, and you want to find the average rate of change from here to here, what's the average slope from here to here? It actually is the slope of this dotted line. That is the average rate of change. Now, why is this important? Because sometimes it's very hard to calculate slope on graphs like this, or even on tables, where we are just given arbitrary information. So, average rate of change does not require calculus whatsoever. People get tripped up on this. They see average rate of change, and they're like, I gotta take a derivative. No, you have to go back to Algebra 1. Algebra 1 students can find the average rate of change of things, okay? It's just a slope of a secant line through 2 points. That's all it is. Okay? So let's do number 1. An experiment of population of bacteria in Nilish's bedroom. Find the average rate of change from P to Q. I got him. Draw in the secant line and show your computation. So we're going to go from P to Q. So from here to here, I want to find the slope. I'll just draw a dotted line. The slope of that dotted line. So all I'm going to do is, from P to Q, it doesn't matter which one comes first. It's got to be consistent on the top and bottom. That's it. So I'm going to do, well, does this even have a function name of it? No, it doesn't. So we're going to do the y value of Q. So we're going to do 340 minus the y value of P, which is 150, all over the x value of Q minus the x value of P. Now, information, because I'm not going to do it. I'm relying on you. What is this answer? Three, 8.6. Did you know that answer? Okay, so we in the case of math, any problems to do, we're getting answer and you know. Sure. Why this is bacteria, or the of bacteria per day. This question very likely comes up. Okay, here are the point here. People forget to do the credit. Answer point. Your unit. Third could have no going on a point unit. You type it wrong and put bacteria per day. Get 1. Actually, no, should get 2 if you set up correct. Point not labeling. Don't lose this point because they write down your calculator. And number 2. The table where F is the population and estimate F865. Show the combination. That's your answer. The average of change will be F derivative. So we need to estimate what our rate at 1865. So what values do you think you can pick out to be endpoints to estimate? Probably two guys unboxing. You want to do this one because that will give you 865. Now, did you do 850 and 18? You could get rid of it. Not accurate at this one. 8 and let me do boulders. Now, so this on this bottom was y value. So I'm going to do 38.6. Right. 8 point minus 1 4. All over minus 1860. Somebody that's English? Calculate. This was not bad. You can figure this one out. I don't know if you really want it. What is it? 0.72. So it's population. It doesn't really. So is it people? This is a terrible problem. This problem will never show up in 80 because it doesn't tell you what it is. So millions. We'll just say this is of people. Of people per. Alright, and then here's an example where we have a function. So roller coaster has largest drop followed by the equation right here. So this S, by the way, means position. S of t means position. Also, if we have an X of t, that also means position as well. So just kind of be aware of that. X of t also means position. What is the room for? Just using here can be very bad to us. It would be I would, okay. And to go, all I'm gonna type this in, double check my type in so I'm not like, no, I want to leave this that no one receives. So I type in, make sure, hopefully, check what we're doing here is we are going to find s of 6 minus s4 all over 6 minus this full for the setup. Okay? Type in all these values, everything. This is full right here. S of 6 s of 4 over 6 minus 4. So let's go to our handy D calculator. Go ahead and do this. Let's go to our home screen, hit alpha y1, enter, that gives us a fraction. So here we go. So I'm going to do sx y1 minus s of 4. How much am I actually doing right now? I'm just knowing how machine. I'm literally typing in everything I wrote down. I'm not need your thing, I'm making it derivative. So you hit enter and then kablam. Did your answer match up? Okay. I got 0.6. You got point? Yeah. Let me just check my work here. Alright, now, boss, did I type everything incorrectly? Did I type incorrectly? I'm guessing I did great for teaching. Got it. Or maybe you. 113. Is that seriously that much of a difference? No. Is that what you? Okay, so what everyone got? Okay, we're good. Alright, hey, quiet. Alright, for this one right here, when I actually ink, because what I get, I'll just ink down, negative 57.9. Okay, what does that negative represent? Alright. Makes sense. Alright, instantaneous change. This is not what? This is represented in any degrees. This is the technical definition of prime of, okay? Alright, so this is F, this is the technical definition of like this, but what we have done is apply it. Number 5 here, roller coaster, it's the same thing. But the question's asking, find the instantaneous rate of change at exactly 5 seconds. So we have a calculator in our hands. We just did this. What do we do? We find f into y1. So we find the derivative respect to x at y1 equals 5. This is why it's in a y1. Question part, this could easily be less work. So enter and then hopefully the same. Did we all get the same thing? Yep. So good enough. Questions and 4. 5. Okay, do our calculator. Actually, 4 calculator. No, I could have did it by hand, but it's just a little easier that way. We'll do this one by hand. So how do we this one out by hand? So I'm gonna do a real quick read. I'm gonna rewrite this middle term a little bit easier. If I write it as 5 or 5th x to 2 minus 4s. So f prime is equal to. I hear a lot of talking. Maybe this is why our grades aren't great. Can't be a teacher. I'm too.
I agree with that.
Thanks, drop it. Sometimes people put in comment videos. I don't know who they are. Something happen. I don't because sometimes people from like Sweden watch my videos. Like I'll do like a quick I'll look at the stats sometimes at the end of my unit like who watch my videos and I kind of see and they're like globally. I'm like I would assume everyone from like the Dallas area would be watching it and there'd be like a couple in Canada, a couple in Sweden, there'd be a couple in I don't even know somewhere in Asia, some countries I don't even know how to say. Some African country, like it would just be like randomly, like everywhere. Like wow, these videos are really a big international hit. Okay, so So f prime of 2 is going to be when I plug in a 2, so I'm going to get negative 3 times 2 squared minus 6 over 5, 2 to negative 3 minus 4. So we can actually do this. I'll do this above it. So what's negative 3 times 2 squared? Good class, negative 12. 2 to the negative 3, that's not negative 8. It's 1 over 8. So I have 1 over 8 times 6 fifths, which is 6 40ths, 3 20ths, minus 4. So this is going to give me a 16, negative 16 minus 3 over 20. That right here would be a good enough answer. Actually, this answer right here is good enough too. I want to make it, simplify it, would be negative 323. All over 20. So there we go. Just looking. I feel like right here is a good little stopping point before we actually start talking about velocity and everything. So average rate of change, instantaneous rate of change, it's all good stuff. We're going to pick this back up next class.